At a slack bus, which one of the following combination variable are specified? So I again draw the table, which is like generator, bus, load bus, and slack bus, and then known and unknown quantities. So in this generator is PV is known, for load PQ is known, for slack opposite of load means whatever the load is unknown, that is known to slack bus. So we write here V and delta. So V and delta is known for the slack bus. So V and delta, check V and delta in option A is correct. Okay, I hope you understand. We have solved this in previous also. Next, consider following quantities here about real power P, quantity reactive power Q, power factor cos phi, input current I, voltage magnitude V, and delta phase angle. So which are the load flow studies in the each bus node associated with which are combination of above four quantities. So always remember, at each bus P, Q, V and delta, these four terms are mentioned, or say mentioned, not say mentioned, but these are the four quantities which need at each bus. So check the option which is correct. 1, 1, 2, 5 and 6, option D. Okay, option D is correct here. Next, which one of the following statement is correct? Normally Z bus matrix is, now remember, Z bus is full matrix, and Y bus is, you can say, sparse matrix. Null means all quantities are zero, means null matrix. Unity matrix means 1 1 1 1, that's called unity. Or even not like this, even this is also unity. This is correct, unity matrix, identity matrix, unity matrix. So here the answer is option C. Option C is correct. Z bus is full matrix. Next, assertion. Here assertion is and reason. The main advantage of decoupled method is compared to Newton-Raphson is to reduce the memory of requirement in storing the Jacobian, and given the reason is an important characteristic of practical power transmission system operating in steady state is a strong interdependence of a real power voltage angle between the reactive power and voltage magnitude. So here I want to mention about like DLF, this DLF method. The real power P, del P, if I say del P changes, means change in real power is less sensitive to changes in voltage magnitude, while del Q means changes in the reactive power is less sensitive to change in angle, which is delta. So from this it is accurate, means assertion is also correct and a reason is also correct, because it is interdependence between these terms P, V and change in reactive power and voltage angle, and it is happen in DLF means fast decoupled decoupled load flow method, and which is superior, which reduce the memory requirement which has required in Newton-Raphson is much more than DLF. So this means assertion is correct and reason is also correct, and they follow each other. Next, consider the following statement irrespective of load flow study in power system. The bus admittance matrix y bus is sparse. I hope we just see sparse matrix. Then second is saying Gauss-Seidel is preferred over Newton-Raphson. No, Newton-Raphson is preferred over Gauss-Seidel, so this is wrong. This statement is correct. This is correct one. Then third one is the one of the bus is taken as a slack and load flow, so this is also correct. So and why this is correct, so wrong term is second, so option 1 and 3. Option C is correct, 1 and 3 is correct. I hope you understand this. Next, buses of a load flow study classified as load and PV and slack. So again we have just check now what is, say, load bus and generator bus. I write just this thing. These are the known things. Known generator for load for PQ bus. Now check the option just for this. If I say load is PQ, so here is mention about load is PQ, PV is this, and slack is this, so option B is correct. Next, a sample of power system network is shown in figure. Reactance marked in per units. Now reactance is mentioned, means impedance you can say, and we have to calculate Y, means admittance matrix. In that Y22 we need to calculate. So same, we will convert this diagram into a even if we not convert, we can write directly Y22 equal to like Y21. We can check in the diagram Y21 is connected, then Y23 is connected, Y20 is connected. 20 means we can write 20 means itself 22, because we have to consider 22 itself, no, that's why I write 20. Y21, if I write Y21 is equal to 1 upon minus j 0.2, not minus, just j 0.2, which is j5 per unit. Then Y23 is equal to 1 upon j 0.2, which is equal to minus j5 per unit, and then Y20, which is this you can say generator, that's why we have to consider this term. This is for generator, okay, not with the ground. Then 1 upon j 0.1, which gives you j10 minus j10 per unit. So total Y22 is equals to minus j5 plus then minus 5 j, then again minus j10, it gives you minus 20 j per unit. So option D is correct here. Next, which one of the following statement the element of which each row Y bus matrix load flow study in power system are added up to 0 when it is not always the this. If shunt admittance of bus is ignored, this is correct. Mutual coupling of transmission lines are absent, yes, this is also correct. So option D is correct. How I can tell you, if it is, this is kind of matrix. If I say example minus j3 j5 0 0 minus, let's say take j5 minus j5 minus and plus j2 j8 and another, I can wait now, I take a small matrix, otherwise it will be a complicated, minus j3 plus j3 and 0, and random numbers I write it, then again minus j2 j3 and j5. So if we consider now here, the sum becomes 0, but here sum is not 0, means these elements are present, means whatever the bus 1, if it is, this is 1 and this is bus 2 till ground, there are some elements in between of them. Okay, if there is element between them, if we say here I write draw and again here also. So now if we say addition of this minus j2 plus j3 plus j5, which gives you something value which is 8 minus 2 is minus j6 plus j6, so j6 here, this is the capacitor value is connected, so it is not 0, that's why. While if we said 2 bus is directly connected to 0, so there is no elements connected, means no elements connected till ground, means bus 2 to ground, no element. Here there is one capacitor is present, this bus 1 to ground, there is one capacitor is present, that's why valuation is here not getting 0. I hope you understand. Option D is here correct. Next, assertion, a bus admittance matrix is sparse matrix. Now we know about it, why bus is sparse matrix, and reason this is correct means assertion. Now reason is saying in load flow study, one of the bus is taken as slack. Slack is consider as one of a bus. Now reason is also correct, but these two are not follow each other. Okay, that's why option B is correct, means here assertion is correct, reason is correct, but they not follow each other, they are not even connected with each other also. Next, what is a form of Y bus matrix for carrying out the load flow study of a Gauss-Seidel method, having mesh connection of a nodes. Now always remember, Y bus is symmetric and not diagonal matrix. Diagonal means only diagonal elements are present, like this, and other are 0. This is never a Y bus. This is you will see diagonal elements are present with some values in some of the values mentioned. Like if we say symmetric means, if I say y is equals to y11 y12 y21 y22, here y12 is minus of y21. This is what say we symmetric. And diagonal, if we say diagonal elements, if it is 1 2 bus, this is 1, this is 2, and connect with some 0 means ground, so there must be a y11 there is connection, means like we have to write it like y112. I can write it again here. y11 is equals to y12 plus y10. Similarly, y22 is equals to y21 plus y20. So there is elements mentioned, so it can't be a diagonal matrix. That's why option A is correct. Option A is here correct. Next, for a graph of power system network shown in figure below, where the bus numbers are impedances marked. Now impedances marked means this is Z, and we have to find the Z22. Now this is how many nodes you can check. This is one, this is one, this is one. These are 4 nodes. If we do in Y bus, it will need, means this is Z. If we convert into a Y bus and then again this to Z bus, the inverse we take, it will be 3 by 3 inverse, which is difficult. That's why we will go with Z bus. How we will go with Z bus? We will take 1 by 1 bus. So take first 1 and 0, and here if we say 1, so I write Z bus is equals to 1. Now again we connect with the 0 to 3, the value is 1, and then 1.5 here. Then I can write Z here. Take carefully each valuation. 1 is mentioned here, need to write in form of like here it's so start from 1 to 1. Now here we start with 1 and 3, 1 and 3. So writing value 1 is 1, which already right. Then check in diagram. Diagram is this diagram. In this diagram, now 1 3, there is no element. 3 1 is no element. 3 3 means 3 0 is considered 1.5. Now I will draw remaining circuit. 3 2 0 1. Now here is 1.5 and 2. If I write Z whole term, now I write first value of each, means points, buses number 1 3 2 1 3 2. Now whatever the value we have write above as it is, write 1 0 0 1.5. Now check with 2 bus, 2 and 1, there is no connection. Same 2 and 1, there is no connection. Now we go with 2 and 3. 2 and 3, there is 2. 2 and 3 2. 2 and 2, there is only no, there are, we go till ground. This is very important here. This is very important. So we have always go Z bus till ground. Okay, that's why this valuation take every bus 1, even 1 3, or also we calculate this term till ground. Okay, all diagonal elements. So we have to rearrange now. This thing is equals to, means we will write now 1 2 3 and 1 2 3. Okay, so it will be 1 0 0 0 0 3.5 1.5 1.5 and 1.5. I think we made mistake or not, because 2 3 is 1.5. wait a minute, I made mistake somewhere. 2 3 is 1.5. So now we will go with 2.22. No, we will no, I think it's correct. Now we have to calculate Z22. So go just check where is 22. This 2 and this 2 means this is 22. Z22 is 3.5. okay, so option check 3.5 is option B is correct. okay, I hope you understand this method of Z using in this calculation. We never get this kind of calculation, but if it prefer only Y bus matrix, it will be easier, but taking inverse of 3 into 3 bus is difficult. That's why we go with Z bus. Next, load flow study must be made on a power system before making short circuit studies, but not transient stability. So this is wrong. The making transient stability study but not short circuit, this is also wrong. Making short circuit and transient stability, this is correct. And last about saying neither and not of transient and short circuit study. So first we do load flow study, V PYQ del, this gives you about losses, and then from this we go with the stability studies, and in the stability studies we mainly do with a transient and short circuit study. So that's why both are required, transient and short circuit, both we will calculate after, means before the load flow studies must be made before, means first load flow study studied, and then stability of transient and short circuit of power system perform. okay, next assertion is load flow study usually carried out Y bus because Y bus is sparse. okay, so that's only the reason also mentioned. Y bus is sparse and it generally topology of networks. So assertion is correct and it follow the reason also. The reason is also correct, so option A is correct. Next, in Gauss-Seidel load flow method, number of iteration may be reduced if correction in a voltage at each bus is multiplied by. Now Gauss constant is related with the Gauss laws, and it is not with the Gauss-Seidel method, but still it's not a here to reduce iteration reduce, we can't reduce iterations. In a Gauss-Seidel mostly we know if size means system size increases, then iterations are also increases. So and also system goes slower, and this now Gauss constant done. Blocking factor, which actually we don't know about it. Lagrange's factor is used in for large system, and in Gauss-Seidel, here question is about Gauss-Seidel, and we are using if Gauss-Seidel for large system. Lagrange's multiplier is used mostly in NR method, Newton-Raphson. So remaining is only acceleration. What about acceleration factor? Acceleration factor actually converges this method, so, and it also slower the convergence or divergence. That's why option B is means acceleration factor is multiplied at each bus, so that the convergence or divergence are we can able to perform, and we can get the output of power, reactive power, voltage and angle at voltage angle at a bus, particular buses. Next, consider following statement regarding convergence of Newton-Raphson procedure. Now if we say Newton-Raphson procedure, firstly I write some information. Newton-Raphson method. Now it is, we solve first algebraic and transcendental equations, and then we numerical solution. It is a numerical solution, so it is numerical solution. So shape or say slope does not have any effect on roots of equations computed by this method, means NR method, and it is preferred because less iterations. Now check lines one by one. It does not converge at the root when second differential coefficient changes. Now this is considered. Second line is, it is preferred when graph of x is nearly horizontal to x-axis. So this is not about this. Shape and slope does not, this is line. I write shape and slope does not have any effect, on roots of equation. And third is about, it is used to solve the algebraic and transcendental. Now that is also I mentioned transcendental and algebraic equation. So option 2 means 1 and 3 is correct. Option D is here correct. I hope you understand here. Next, the line reactance of power network is as follow. So we have to draw this diagram according to the buses. So if I say 1 and 2, 1 2 1 2 and the ground 0, and if we draw as per the given table, if I say 1 and 2, is it 1 from bus 1 to 0, 1 to 0 is 0.2. okay, 1 from 0 to 1 is mentioned as 0.2, and then 1 to 2, from 1 to 2 is 0.4. How I write? This is mentioned from bus to bus, 1 to 2, 2 to 1 means 1 to 2, and 0 to 1 is mentioned. So I write this term. Now this is what is it? It's a reactance. In short, it is Z. Impedances. Impedance means Jx. Okay. Now we have to calculate the bus impedance. Now we have to calculate Z. Okay, Z bus. Now we first calculate Y bus, which will be easier also. So we will convert first this diagram into a Y. So I write again 1 2 and then 0. This is 5, this is 2.5. so from this we can write Y is 1 1. I directly write 1 1. 1 1 is connected with 1 is 2.5 and 5, then 1 2 is 2.5, here 2.5, then 2 0 means 2 2 is also 2.5. Now we have to convert this into a Z, means inverse, taking inverse. How we take? This is multiplication, 7.5 here, 7.5 into 2.5 minus 2.5 into 2.5, and then here changing the position, this and this positions are changed in taking inverse, and remaining are signs are changes. Actually signs are here itself is change, because we consider as negative terms of diagonal element negative, that's why these are positive in Z bus 2.5 and 2.5. so now if I calculate these term, it will take 2.5 common, so 7.5 minus 2.5, and 2.5 we take a common and divide it to each element means 2.5 divided by 2.5, 2.5 divided by 2.5, and so on. So at the end what we get, it first is 1 by 5, and then 1 1 1, and then 3, and now at the end it will be 0.2 0.2 0.2 and 0.6. so check the option, which one is option C. Option C is here correct.